Hello and welcome to this video on how to do unit conversions for greenhouse gas emissions calculations. My name is Lucas Fraser. I'm the Chief Technology Officer at Breeze, and we're going to go through how to do unit conversions for emission factors and activity data in Excel as well as in Breeze. So today we're going to focus on basically everything that's kind of outlined in this blog post that we have about how to do unit conversions for greenhouse gas emissions calculations. This explains kind of the context, the purpose, and how to go through different unit conversions. We're going to go through the same example in both cases. We're going to use this emission factor purchase energy for electricity in the United States average from the US EPA. This is a relatively up-to-date emission factor, and we're just going to go from the unit that it was published in all the way through to an end calculation based on activity data. So to start off with, looking at this in Google Sheets, we are going to go through this from start to finish. So first off, we'll just come down here. You can go to the Greenhouse Gas Emission Factors Hub and download these emission factors if you'd like. That's generally how you can access them. They're also all available in the Breeze website. You can search for the right emission factor followed by mybreeze.io, and you'll come up with it. In this case, we'll skip this because we know that the values are listed here. And so the unit of measure, so the activity data unit, is going to be megawatt hours in which it's published. And the unit of measure of the emission factor is pounds. Just refresh the page here. And so we're looking at pounds per megawatt hour is the value in question. What we want is, let's say we receive our electricity data in kilowatt hours, and we want to publish this in kilograms or tons of CO2 equivalent. How do we go through that whole process? So what we have here is, let's just go through and add these values in. So it's 852.3 pounds, 852.3 pounds per megawatt hour. Let's just call this let's just do some adjusting here. This is just a basic worksheet unit. And let's add one more column for description. If I was to do this in Excel, I would do a process similar to this. You might have a number of columns for each emission factor, but since we're just doing one emission factor, we can keep this relatively simple. Let's just call this value. From there, so that's 852.3, and then this is 0.071 pounds. And I'll update that description as well. Just watching me do some data entry here. CO2 emissions per CH4 emissions, N2O emissions. And we're going to need to do a little bit of an additional adjustment here as well, but CO2e intensity. So this is the value we're going for. We're going to confirm that we get to the correct value. But our end result should be in metric tons CO2e per kilowatt hour. So we have to do a couple lookups here. First of all, we're going to convert everything from pounds per megawatt hour to, let's just go with kilograms per megawatt hour. So honestly, what you can do is pounds to kilograms. So 1 pound equals 0.4535, something like that. So let's just add that value in here, and this is kilograms per pound. Is that correct? Let's just see, 1 pound equals this many kilograms. Exactly. So unit conversion. And now let's just do the same thing. Converted. This whole process can be done in Excel, and you'd end up doing this for each emission factor. This is also hyper simplified in Breeze, and so we'll come back to that as well. So what I'm going to do is this. Essentially what you just do is you multiply the numerator first. So pounds equals multiplied by the unit conversion factor. And then we'll do the same thing here. Don't have a function key, so just freeze that. And we get the same thing. Boom. So now the number's lower. Pounds are way less than kilograms, so the number should be lower. This is going to be kilograms per megawatt hour. And then the next thing we need to do is figure out from megawatt hours to kilowatt hours. So let's just do that. And you can obviously look for correct sources. For all these standard unit conversions, you can generally trust Google, but you can also find official sources if you're doing this for audit purposes or anything like that. So this is the number of kilowatt hours per megawatt hour. Gotta get those units correct, and we'll call that unit conversion. So now we'll do the same thing, but instead of that, we will have kilograms per kilowatt hour. And we'll just do the same thing, this, and so you go divided by that unit conversion. Now that's starting to look pretty okay. Got this. Let's just freeze that value. And the nice thing about bringing all of these values, keeping all these values as formulas, is that you can always go back and find where you did that calculation and what the formula was and what the original values were. Oops, not that. Just pull this out into a standard number of decimals. Okay, so we will need a couple more lines, and the last thing we're going to do here is just convert these all to units of CO2e. So the next thing we want to have is kilograms CO2e per kilowatt hour. So let me just pull this down again, make sure we're always labeling everything we're doing. Just grab that. And forgive me, I'm going through every step just to be exhaustive here to show you what this full process looks like if you're doing it in Excel. So what we need next is a GWP for CO2, GWP for CH4, and GWP for N2O. And I will just go through the whole process here. So we're looking at GWP AR5. That's what we're going to be looking for, global warming potential values here. This is from the Greenhouse Gas Protocol based on IPCC AR5, or the fifth assessment report, AR5 right there. You can see they show the different assessment reports. As of right now in 2024, the fifth assessment report is the most up-to-date with GWPs, and they've actually updated these to increase the global warming potential of some of these gases after doing some further research. You can see it's 128,265. So we'll just bring those in, 128,265. And those are the GWPs that we're taking into account here. I'll actually bring that into the values column, and I'll just say GWP. It's essentially an index. It's how many units of CO2e per unit of CH4 or N2O. And so we do the same thing. This times this gives us our value there. And we do this because the US EPA does not publish their emission factors in units of CO2e. They publish them in units of CO2, CH4, and N2O. So you have to convert them to the equivalent CO2 value. And so what we have here, we're down now to kilograms CO2e per kilowatt hour of each of the three gases. And so in some cases, like if you're reporting to CDP, or you're putting out any sort of broken down reporting by greenhouse gas, you can use these values, or you could even use these values depending on the unit that you publish them in, because this is kilograms of CH4 per kilowatt hour emitted. What we have here, though, is each of the individual gases represented as units of CO2e. So you can see it's 0.083 kilograms per kilowatt hour of CH4, but it's 2.3 kilograms of CO2 equivalent per kilowatt hour of the same gas. So the impact of that CH4 and N2O, or methane, is much higher. Finally here, what we're going to do is produce this final MT CO2e per kilowatt hour value, just so that we get the final emission factor. US average electricity. And I'll just bring in this source so we have that record. So if we add this all together, we have 17 metric tons per kilowatt hour. Just going back, I did have a little mistake in here. You can see here this multiplying or dividing B11 by B14. Just going to go ahead and correct that. Down here, we've got it by 15. I just froze the wrong cell. So you can see here, 14. Let's just grab that and we'll go add another freeze. Boom, boom, boom. There we go. That's looking better. And so let's maybe just bring out a couple more decimal places here so we can see what we're looking at. Okay, so I've gone back and just corrected a quick error. There was a little issue with the freeze on this cell, so I was multiplying by the wrong conversion factor. Just checking back against the source material. So it's important to make sure that you freeze the correct cell when you're doing these formulas. These ones look like they're all good. So we're all set here, and it looks like those end results have conformed a little bit more to what I expected. So this here is the kilograms per kilowatt hour total. Let's just go ahead and call that the kilograms per kilowatt hour. But like we said, what we are going for is the final EF in metric tons of metric tons of CO2e per kilowatt hour. Sorry, I minced my words here. What we have, so we would take this one more unit conversion factor, which is 1,000 kilograms per metric ton, or you could say 1 divided by 1,000 for the number of tons per kilogram. This is a unit conversion. And then again, we get our final EF will be this total CO2e in kilograms times this total CO2e in metric tons. So you've got 3 zeros, 388. If we come back here, got exactly the same value. So everything's looking correct. This is how you do it in Excel. And this is the metric tons of CO2e per kilowatt hour for US EPA average grid electricity. Now let's go through how to do this in Breeze. So what I'm going to do here is I just created a brand new account, starting from square one. Right after you enter your email, you get to this page. I'm going to continue with free and just give this account a name. We'll go with newcomer path. Let's call this unit conversion factor demo. Just hit save there. And then I'm just going to skip the onboarding. You can do this at any time. You just grab setup manually, skip onboarding, and it jumps straight to the home page. You'll have nothing configured in the system. A couple announcements. We come to the map page, add a source from a template. Let's go. Electricity United States average, just to confirm that this is the correct one. We can open up the dedicated source template page. This will have a bit of a description of what's going on here, as well as which emission factor is in use on that one. If we jump to this, you can see that it is the same emission factor here. Exactly the same page, exactly the same value. And so let's come down here, we'll grab that one, select that. You can see it pulls in the emission factor, even market-based emissions are active, and we're connected to this source template. Go ahead and click save here. We can put this in maybe purchase energy just to make sure that it's classified correctly. Now we have a source. We can just go right in and add data. And let's say we have 1,001 or 10,001 kilowatt hours of electricity. You can see you can use any unit of measure here. So we could do it in therms if we wanted to. We have all these conversion factors in the system. Kilowatt hour, go through, and this, let's say this is for the full year, 10,001 kilowatt hours, and let's just call this estimated data. Let's go demo and click save. And now all of a sudden, we've got a value for our reporting year of 3.89 tons. If we come in here and let's say we do one more calculation, we have 10,001 kilowatt hours purchased, and we multiply that by our emission factor, we get the exact same value there. Just taps it. There we go. There we go. And that is how you do a unit conversion factor in Google Sheets or Excel, as well as in Breeze. So this is metric ton CO2e total. That's our end calculation. If you want to do your emission factors and your calculations Excel, this is how you do it. I recommend going with Breeze. Everything gets a heck of a lot simpler. If you come over to the data point, you can come in and edit that. You can look at all the calculation steps, advanced fields, emission factor in use, all that good stuff. Market-based emissions are also calculated. You can use a different emission factor. There are tons of reasons to use Breeze for this. I highly recommend it. You saw it took about 10 seconds, whereas doing it in Excel takes a lot longer. But that's the approach. That's the methodology. Thanks for watching this video, and I recommend giving Breeze a try. Thanks.